All right, welcome everybody. This is Michael Crossfox, and today's DELISA webinar is on the subject of exploring NASA resources for the eclipse that's going to occur in April of 2024. I'm joined today by Christina Milat, who's an education specialist at the Heliophysics Education
Activation
Thingamabob.
team.
Okay,
Yeah.
activation team. Okay, I got
Or
that
NASA
for
Heat.
Heat. Okay, at NASA Goddard Space Flight Center. Uh, so this is a very special thing. I'm really pleased. I recently moved to Buffalo, and Buffalo is going to be in the totality of this eclipse. So the entire city is really motivated and mobilizing. They've already announced that public schools will be closed so that the students can engage with community partners like Buffalo Public Library, State University of New York, Buffalo, the Buffalo Planetarium, Buffalo City Museum, Buffalo Science Museum. So the kids are going to be out in the streets. We're all going to be out in the streets. Hopefully, it'll be a bright and sunny day until the 2 o'clock hour when it'll be eclipsed. And so there's a lot of information about this. And so we've invited Christina here to talk to us about how librarians can access NASA resources because, of course, with any eclipse, with any celestial event, our good friends at NASA uh, really go out of their way to provide resources to the public. And a lot of these resources are free and available, but now is the time to act and start thinking about it because we don't want to be caught the day before hearing about the coming eclipse on Good Morning America and not being prepared for dealing with it and for programming. So welcome, Christina. Uh, Take it away. You can go ahead and start sharing your screen and walk us through some of the NASA resources available to librarians and other educators around the country centered around the upcoming eclipse in April of 2024.
Great. Thank you so much for having me. I'm really looking forward to sharing our resources with librarians who are some of my favorite people and really impactful in the community. Are you able to see my screen okay?
Yes.
All right, perfect. So this is the table of contents. I'll be giving everyone access to this slideshow. I'll give Michael a link, and that way you can find all of the resources and here in one place, and navigate and look for things that you will find useful for your community. So I am an education specialist for the NASA Heliophysics Education Activation Team, or NASA HEAT. And my group basically supports all sorts of educators, informal educators, formal educators, librarians, um, with the understanding of the sun and its effect on Earth and the solar system. Heliophysics education activation is needed because while many people are look at the sun every day or experience the sun in some way, you should look at the sun. Um, they don't know a lot about it and the physics behind it, and it's really inspiring to learn that you live in the atmosphere of a star. This is our star. It's incredible. It provides everything we need, and so learning about it can be really exciting for all sorts of learners of all ages. We also have a huge amount of resources, and a lot of those I'm going to be sharing with you today. So just a little bit about heliophysics. The study of heliophysics attempts to understand the nature of space itself, including how the sun's magnetic fields and particles affect space throughout the solar system. Near Earth, such effects are known as space weather, which can interfere with our communications and satellite technology. So knowledge of our space environment really helps us understand the region where our spacecraft are, where our astronauts are, and it actually provides clues to the forces that even forged the planets and other stars. There are billions of stars in the Milky Way galaxy, but the sun is our closest star and the only one in our solar system. The sun is made of ionized gas called plasma. It is about 4.5 billion years old and will continue to create energy via nuclear fusion at its core for another 5 billion years or so. So we've got plenty of sunshine left in our days. The energy created in the core from fusion of hydrogen into helium travels through the layers of the sun and radiates out into space. The sun actually goes through cycles. It has its own seasons. And this cycle lasts approximately 11 years. It goes from minimum activity, which you can see on the left, to maximum activity, which you can see on the right. This is dictated by the magnetic fields on the sun. Just like on Earth, the sun has a north and south magnetic pole. And when it's nice and quiet, the poles are stable, but they switch about every 11 years. And when they switch, those magnetic field lines get tangled, they snap, they reconnect, and they create a huge amount of energy, which results in sunspots, solar flares, coronal mass ejections. And these solar storms will make something called the solar wind. And if you think about, weather on Earth, it's kind of like a hurricane season, where the solar wind intensifies. It causes fluctuations in the Earth's magnetic field, which again can interfere with our technology and our communications infrastructure. So understanding the behavior of the sun and how it affects Earth can help us predict space weather and protect our satellites and our astronauts. So, why teach heliophysics? I sort of gave you some good reasons back there. It's a pretty exciting field of study. But really, learning about heliophysics is understanding the fundamental physics of space that surrounds us, and the space and the rest of the universe. And it gives us clues about what makes planets habitable. Earth is the only planet we know of right now that is habitable, but we are actively looking for other planets orbiting around stars that are similar to our sun, in that perfect right spot distance between the sun and the planet, to look for the possibility of another planet that could host life. So while we're familiar that sunlight enables and sustains life, we also know that it produces radiation and this intense magnetic energy that can disrupt planetary atmospheres. For example, the Mars has a very thin atmosphere. Mars doesn't have a magnetic field, so basically the solar wind has blown away Mars's atmosphere, literally. So but that solar wind actually it extends far beyond Pluto, and it actually acts like a shield from radiation and other factors of interstellar space. So actually the space around our sun is slightly different than the space outside of that protective bubble. Like I said, Earth is the perfect distance from the sun to allow for the existence of liquid water, which is a requirement of life as we know it. So to find other possible habitable planets in the galaxy, NASA looks to stars that are like our sun. So we had a recent solar eclipse, an annular solar eclipse in October. And then of course, especially for y'all in Buffalo, the April 8th, 2024 eclipse is going to be especially exciting because you will be in the path of totality, like Michael said, and I'll talk a little bit more about that. Engaging learners in making observations during solar eclipses can help reinforce STEM skills, and it sparks interest and wonder in scientific phenomena. NASA studies solar eclipses to learn more about the Sun-Earth relationship. And a total solar eclipse provides a unique opportunity to study the sun's corona, which is where that solar wind originates from. So here are just a few highlights. My team was in Albuquerque, New Mexico for the annular eclipse in October at the Balloon Fiesta, so it was pretty special. You can see here, I just snapped a few photos with my iPhone, so, not too bad actually. But this particular eclipse causes a ring of fire. And that's because actually the moon is just a little bit farther away from Earth in its elliptical orbit. And so it appears a little bit smaller in the sky. So it's about 90% coverage. During this eclipse, you would still need to wear your glasses the entire time. I shot this through my solar eclipse glasses through my camera lens. We'll also talk about other ways that you can experience the eclipse through pinhole projector, which projects the shape of the sun as it's eclipsing. And then really just you can stand under a tree and the leaves on the trees make these wonderful shadows that you can see on my colleague here, Pat, and on the ground. So this is a great resource that I'm going to start off with. You can download this map in several sizes and print it and display it in your library or your space. It shows the path of annularity, which was on October 2023. If you were inside that path, like in Albuquerque, the sun appeared as a ring of fire. It was about 125 miles long or wide. And then outside the path, anywhere in the United States, you'd have experienced a partial solar eclipse. So hopefully some of you saw that. The big event, of course, is April 8th, 2024. If you're inside this path, as Buffalo is, this path is about 120 miles wide. The sun will be completely blocked by the moon's shadow, creating an effect like twilight. That experience lasts up to 4 minutes, depending on where you are. And again, if you're outside of this path, anywhere in the United States, you'll experience a partial solar eclipse. So observers can use this map to help them plan their solar eclipse experience. So you'll know the times of totality and the locations and things like that. I also included this resource. This is a video that just tours the map and shows you about what kind of information you can get from the map. This map was created using an incredible amount of data, including from the Lunar Reconnaissance Orbiter, which is a NASA mission that orbits the moon. You may have noticed that these ovals depicting the moon's shadow are not perfectly smooth, and that's because we've even taken into account the mountains and the craters on the moon and its effect on the shape of the shadow on Earth. It's a quick video, so I'll let it play through. But again, you'll have these resources and you can revisit this video and show it to others who are interested in maps. I love maps. They're a great way to interact with data at a very accessible level.
Now, is there, just out of curiosity, because obviously there's a lot of data about the moon and the Earth, as these are kind of local to the human experience. Is there a NASA GIS, Geographical Information System, for other planets, like for Mars? Like, can we see the data that's been collected by Opportunity or Curiosity on Mars, or is it
Yes,
just?
yeah. So Mars is something we know a lot about because we have a lot of missions. A lot of these missions will use altimeters and laser altimeters so they can uh, scan the geography and the topography of a planet. So, you know, when we have missions that orbit a planet for a long time, we can gather all of that data. And of course, a lot of our outer planets have only had flybys of some of them. And again, that data takes a lot longer to collect, and those planets are quite large. Mars is definitely something that we know a lot about. So that's a great question. So you may also be familiar with in 2017, we had another solar eclipse that crossed the United States. It was actually the first total solar eclipse visible in the United States for 38 years. And approximately 2/3 of the US population lived within a day's drive of totality. A collection of 11 spacecraft from NASA and partner organizations, including NOAA and JAXA and ESA, provided observations of the sun and moon and Earth during the eclipse. In addition, NASA provides other ways to study the eclipse, including WB-57 aircrafts for high altitude observations, and the International Space Station also takes photographs. But this particular image is from one of NOAA's satellites, where we have an instrument on that satellite. It's kind of cool to see the shadow. And so while total solar eclipses happen about every 18 months somewhere on Earth, it often does not cross over large areas of land, or they cross over areas of land that are scarcely populated. So when we have these eclipses going across the United States, and we're particularly excited about this 2024 one because it does pass over so many largely populated cities. And that means more people can experience this wonderful phenomenon. So, and to let you know how special this is, the next total solar eclipse over North America won't be until 2044. Um, so you want to take advantage of this experience. It's actually pretty rare to have to experience totality in a single location. So these little portions here that crisscross that got to see it in 2017 and 2024. Again, that's fairly rare. And the reason it's kind of rare to have solar eclipses is that the moon's orbit is slightly tilted by about 5 degrees. So the objects don't always line up. And this animation, again, a resource that you can access, um, shows you just how that works. Sometimes the moon shadow is too high, sometimes it's too low. All right. So we're going to talk about safety messaging and making sure that your community members are safe when they're viewing the solar eclipse. Viewing the sun without the proper equipment, even for just a few seconds, can permanently damage your eyes. Solar viewing glasses or solar eclipse glasses are not the only way to observe a solar eclipse. A pinhole projector is a simple camera and can be a really cool way to observe the solar eclipse. There are several options for making a pinhole projector. Here's a video that you can access that shows you how to make one in a box. This is kind of nice because it just creates a darker environment for you to observe the shadow. You can stand under a tree, which has the same effect. You can use a colander, but also one of the resources you can access is this really cool pinhole projector of the United States showing the path of totality and the different percentages of the moon, the moon obscuring the sun. We have 3D printed files, so you can just print it out on cardstock, or if your library has a 3D printer, this would be a fun sort of project you could engage folks in.
Hi, my name is Parker, and I'm going to teach you how to make.
We don't need to watch that now.
It is interesting though, because I had never heard about pinhole cameras. I remember the 2017 eclipse. I was at work on the Queens campus, and we just went out, and that's when I first saw that phenomenon where the shadows of the leaves project the image of the sun, or the image of the moon passing in front of the sun. And it just kind of caused a moment of pause and awakening for me, because I didn't realize, or you never given thought, we just take it for granted, that the sun is the source of all illumination on the surface of this planet, going back, since the planet was formed. Um, so when something occludes it, so we can get a sense. I mean, those places that you mentioned a couple of slides ago in the Midwest that have experienced both totality in both 2017 and in 2024, um, you know, what's the folklore like in those regions? What stories would have been told by people living there 10,000 years ago? Like there's so, especially we're a Catholic university, so we know scripture. There's a historical significance, and big events take place, or they're remembered in time. They're kind of immortalized when eclipses occur. So this is, it's a very interesting, but it struck me in 2017 how important the sun actually is to life on this planet, and just seeing that the shadow change shape, and understanding that, oh yeah, all of the light around us, not, I'm indoors, but all of the light around us comes from the sun. I mean, the original idea of illumination is that. So I get excited about this. So
Yeah, absolutely. And, imagine, being an early human on Earth and, you count on the sun every single day, and then all of a sudden it gets dark in the middle of the day. It would have been quite alarming. And, a lot of things like Stonehenge, if you've ever been to Chaco Canyon in New Mexico, they've built huge monuments based on the rhythms of the sun. And it's, there are still some cultures today, indigenous populations that will not view the eclipse because of their beliefs, and it can be, a bad omen. So it's still very significant. People who have seen totality, I've actually never seen totality because in 2017 I was teaching in Maryland, but it can be an emotional experience, it could be a spiritual experience, and it's something you don't want to miss. Thanks for sharing that, Michael. So there's a lot of different ways you can experience it. If you have solar glasses, that's great. If you don't and you have a pinhole projector, that's fine too. If the solar filters are about 1,000 times darker than sunglasses, and they block all infrared and UV light and nearly all visible light. So I like to demonstrate how effective these glasses are by when I'm with my students, or if you're with your audiences, have them put it on inside. It goes completely dark. You can't see anything at all. No shadows, nothing. So and then compare them to sunglasses, and it really is effective demonstration on showing them how effective they are. If you properly store your glasses and take care of the lenses, you can save them and use them anytime for making solar observations. And I've included this video to help guide you to decide if your solar glasses are safe. I reached out to some folks to see where libraries could get glasses. A lot of libraries I know already have them. They got them pretty early because if you may recall, in 2017 there was a bit of a shortage of glasses. There was an incident where Amazon had vendors that were selling glasses that weren't safe. So it's created kind of a panic at this point. When I was in Albuquerque in 2023, people were pretty anxious about getting their hands on the glasses. So right now I'm going to talk about NASA at My Library, which is a great resource for librarians. But right now they have paused distribution until March. So if you do look for another place to get your glasses, reference this video to determine if they're safe or not. So this is a great graphic, sort of a guideline for when you should have your solar filters on and when you should take them off. So during the total solar eclipse, if you're on the path of totality, like you are in Buffalo, you may remove your glasses when the moon is 100% blocking the sun, which is only for several minutes. So you will have to wear your glasses for the partial phases. You can take them off for totality, and then you can put them back on and observe the rest of the partial eclipse. Never look at the sun without protection outside of those scarce moments of totality. And this image also shows you that that's when you get to see the sun's corona, which is quite beautiful. Normally it's way too dim to see compared to the bright surface of the sun, the photosphere. So here are our most recent Eclipse products that we just released. These are specifically made for April 8th. So we have a safety flyer. So again, if you are in your community and you want to, have this available in your library so people know how to be safe for the eclipse, this is a great handout. We have that pinhole projector that I showed you. This is the paper version, but also if you follow this link, you can get to the 3D print files. This is just a fact sheet. There's actually some activities on here that I'll show you. So again, just, for people to wander into the library and grab a quick fact sheet, that might be really helpful. And then for the library walls, we have these beautiful posters that just came out. So we have a double-sided poster here that has a lot of information on the back. NASA is really obsessed with, like, if you make a poster, you have to use all of the space available. So they put a lot of information on the back, which seems a little weird because it's a poster and you hang it on the wall, but it will provide you information on the back. This is a one-sided poster from artist Tyler Nordgren. You may have seen some of his art before. He's been doing art for NASA for quite a few years. And then another beautiful poster that is also two-sided. It shows you some of the geometry of the eclipse. These are brand new resources. So right now they're available in a public folder on Google Drive for you to access and print. And all the files are printable. We also have a total solar eclipse training slide deck coming out. We made one for the annular solar eclipse, and a lot of librarians and other folks found this really useful because when you do have a scientific event or it can be intimidating to communicate the science to the public. So we just want to make sure that you have all the information you need so you can answer any question. Well, not any question, but most of the questions. And I always tell folks if I can't answer a question, let's find out together. I'll find someone who can answer it for you. You will have my contact information, so feel free to reach out to me, and I will find a scientist who can answer your question. This presentation goes through eclipse basics, safety, how NASA studies the sun during eclipses, and other things about NASA missions. So I did give you the link to the annular solar eclipse training to give you a little preview. But again, you will have access to this presentation, so I'll put the link in when that is ready to be published. There's also the official NASA solar eclipse website. Lots and lots of resources here as well. I wanted to highlight for you some of my favorite eclipse activities, and these work really great too for the library. Art activities are always fun. We actually did the Safe and Stylish Solar Eclipse glasses. You take a paper plate and you decorate. And let me tell you, adults loved it just as much as kids. So it is a great activity to do in your community. We also have multicultural eclipse resources. We have our partners. We work very closely with the Indigenous Education Institute and the University of Alaska to bring multicultural resources to a wider audience. I did just a quick sweep of some of the total solar eclipse books that you might want to get for your library for display. So these are some of the children's books, and then these are more informational books, including a field guide to both eclipses. I love the road atlas. I love atlases. So lots of great resources you could get for your library. And also NASA's Braille book. So this is another way to learn about solar eclipses for the visually impaired or low vision or blind folks. So NASA at My Library is a great resource for librarians. NASA, it's a program that works with public libraries, state libraries, and they work together to increase and enhance STEM learning opportunities for millions of library patrons across the nation, including geographic areas and populations that are currently underserved in STEM education. They partner with StarNet, which is basically a clearinghouse or just a database of different resources. So lots of fun activities that you can do, all sorts of stuff and inspired by NASA missions. Another great resources for libraries are the Solar System Ambassadors. So it's a public engagement effort that works with motivated volunteers across the nation to communicate science and to excite people about NASA's space exploration missions. The Solar System Ambassador program has more than 1,100 dedicated volunteers that reach more than 11 million people through both live and online events in their communities. These ambassadors are usually retired scientists or retired NASA employees. I was actually just driving through my little community in New Hampshire a couple of weeks ago, and I drove by a library, and there was a solar system ambassador on the front lawn with his solar telescope. So I did a U-turn. They will bring telescopes. I know some of the libraries also have like telescopes on loan. So those are all opportunities to engage folks more. A solar telescope is really cool. Right now, I talked about solar minimum and solar maximum. Right now, the solar maximum is the sun is getting really exciting to watch. So, those solar telescopes show all sorts of fun features like sunspots and things that you wouldn't be able to necessarily see with eclipse glasses. So you can use their directory, search for an ambassador near you or an upcoming event that's already planned. So beyond the eclipse, we want to inspire people to keep exploring about the sun. NASA's heliophysics division is guided by these three big questions, which are informed by all sorts of the National Research Council decadal strategy. And this is what drives our investigations. This is our resource database. My group, we focus specifically on heliophysics resources. You'll find activities on plasma, magnetism, space weather, aurora, and more. And so check that out. I wanted to highlight a few of my favorite activities within that database. We've got curriculum and lesson plans, quick activities, art activities, all sorts of things for folks at all different ages. And you can keep engaging in heliophysics after April 8th by participating in the Heliophysics Big Year. It's modeled after the Birders Big Year. A birder will attempt to observe and study as many bird species as possible during a calendar year. And it just turns out that this is going to be a big year for the sun. Starting on in October with that annular solar eclipse, the December eclipse, and then one of NASA's most exciting heliophysics missions is Parker Solar Probe, which will fly within 4 million miles of the sun, which is the closest object we will ever send to the sun or have ever sent to the sun. Parker has been making a long, long journey to the sun for several years. It actually takes quite a bit of energy to spiral down towards the sun using several, I think 7 gravity assists from Venus. So it's going to be really exciting when December comes and it gets that close and we can see that data. Also, solar maximum is predicted for 2025. So again, the sun is getting really exciting to study right now and observe, which includes aurora down at lower latitudes. So if we did have a large solar storm, you may be able to see the aurora in Buffalo if you can get outside of the city lights. So I just want to leave you with, your reflection on, your 2024 plans. There are opportunities to engage audiences before the eclipse, hang those posters around your library, create a solar eclipse book display. When that training is available, you can train other people in your community and your staff. Engage families on the weekends with some of those craft activities. Schedule a speaker. I give you a link for this is the official way to schedule a NASA scientist or reach out to the solar system ambassadors, which are amazing people. During the eclipse, you could host a eclipse viewing party at your library. And then after the eclipse, use that excitement to keep engaging folks in STEM activities and participate in that heliophysics big year. So again, contact me anytime you have questions. If I can't answer them, I'll find someone who can. And here's the link to this presentation where you can access all of the links to the resources that I shared today.
Excellent, Christina. Thank you so much. I mean, it's really, again, it's a little bit, it's not, I'm at a loss for words because it's such a massive amount of content and programming opportunities. And that, again, speaks to the fact that we've had this, as a species, we've had this relationship with the sun for all of human history and probably a little bit longer, right? Since we're not that old on this planet. But yeah, so all of this information, I love the idea of reaching out to local volunteers and engaging with them because then that creates a moment where they can just come to the library and hang out, and kind of just have their telescope set up and maybe during school breaks, during spring recess, for when the public schools are out and youth librarians are always looking for programming ideas for break time when schools are closed and the kids flood into the libraries. And these are great opportunities. I know that there's a number of webcams. I think there's an official NASA webcam for viewing the sun, right? It's like the solar observatory or something
Yeah,
where
the
you can.
Solar Dynamics Observatory, you can go in and it will show you updated images every day of the sun in different wavelengths of light. So yeah,
Yeah,
lots of
that's an easy
opportunities.
get for a librarian, right? Just have that URL and then engage with a kid and say, let's, after the eclipse, like let's see what the sun looks like today. Let's see what the sun's doing today, especially ramping up to that, hopefully very active 2025, to keep young people and students engaged with heliophysics before, during, and then after
Mhm.
the eclipse is a good time to, especially I think like middle schoolers, like kids that it could have a real impact and spark their curiosity, and then you can set them on that STEM journey and hopefully get heliophysicists out of it in 10 years. Right. I mean, I try to encourage, my husband's a children's librarian, or he was, and I try to encourage that kind of long-term thinking with youth services librarians. Like, you're going to engage with a kid in a Mommy and Me program when they're 18 months old, and then you're going to help that kid file college applications. So,
Absolutely.
like, think accordingly and plan accordingly, because you're going to find kids, especially kids that are in libraries, are already engaged. They're already learning. They're already
Often.
actively pursuing education. So these are great things great resources to have in your back pocket. Because I think I kind of went through, I was a sci-fi kid, and I still am. Um, but that happened when I was like 12. So,
Yeah.
we
It's a
go through,
key age.
right, we go through like cars, bugs, dinosaurs, and then some kids go to mythology, like the
Mm,
Greek and Roman mythology, and then other kids go into like sci-fi,
yeah.
and that's really the turning point. And my mom got me a subscription to Discover magazine, which was a physics magazine, but kind of like a physics for the everyday person,
Hmm.
and that really inspired me. And then growing up in New York City, having access to the planetarium and stuff, that was really always a lot of fun. But making the connections, like taking something like, I love Star Trek, and what's the real life science behind what we're seeing on those shows, and that was really my conduit into science, and that guided my science education. And also, I'm a violinist, and that also fueled my musical pursuit because I wanted to play the music from Star Trek. So that was that's always, finding these connections. But this is really, we have to be aware, and I think just NASA being giving thank you for giving us the time today, to make us aware of these resources and for sharing them with us. They are our resources, right? I'm a
Yes.
taxpayer, so
Hmm.
everything that NASA does, we have access to. And some of us may
Absolutely.
not be aware of that, but that's always been the case. We can't ride on rockets. We can't just, stop by the ISS whenever we want to, but we do have the privilege, of enjoying the data that's furnished and the science that's produced by NASA. And this is a big part of how we can engage with our communities, in a fact-based, scientifically verified content, right? And that's what NASA
Absolutely.
offers all of us as American citizens. Well, thank you, Christine. I'm just going to quickly round out. I like to end my webinars with what I call housekeeping, which is just a reminder of our students of upcoming dates. Uh, December 11th is when tuition is due for the spring semester. And after that, the university will be closed from from December 22 to January 2, for Christmas recess. So thanks again, Christina, for joining us. I wish you all the best, and I hope you enjoy the totality of the eclipse in April, and have a happy holidays, and we'll be in touch.
Thank you for having me, and thank you to all the librarians out there that are making a difference in their communities.
Excellent. All right, so I've